Join the leading industry experts at PCB Detroit on June 2nd and 3rd for talks on circuit board layout, engineering, signal integrity, manufacturing, high reliability electronics, artificial intelligence, and more. And meet top suppliers of software, materials, and manufacturing services. Can't make the conference? Join us for a special reception at 5 p.m. on June 2nd. PCB Detroit takes place on the campus of Wayne State University. Visit PCEA.net for details.
This is Mike Buetow from the PCEA, and I am with Geoffrey Hazelett from FreedomCAD and Matt Leary from Newgrange Design. And today we are talking with Britton and Nataliia Matsiuk. They are here working on an AI solution for the manufacturing side of the PCB industry. They are participating in a Department of Energy academic program that aims to get scientists out of the labs to learn what problems the industry faces. We are coming from the floor of PCB East, where Thomas and Nataliia have been talking with PCB manufacturers about the DOE program. Thomas, why don't you explain a little bit more about what your goals are?
So we work on technologies in the laboratory. I try to enhance the science that I do, and I don't get outside much. And so the DOE has programs to get me out of the lab, talking with industry experts to figure out what's going on in the real world. And so our aim here is to learn as much as we can about the industry, current state of the arts, and what problems and challenges are being faced, so we can better tailor our solutions to maybe being applicable to help the industry at large.
When you talk about those solutions, can you get into any detail about that?
So I think where we see a lot of value is sitting above the manufacturing process. So there's a lot of data being produced. It's very complicated, lots of steps, and taking the data from those steps and aggregating it and understanding the manufacturing process as a holistic entity, as opposed to, there's a problem here. And then we stop the line and can we make something adaptive and reactive utilizing that data coming from the manufacturing line? That's kind of, I think, where we see our ad for AI, the ultimate goal.
And are you hoping to actually develop a product that's going to do this, or are you going to advocate and support others that are going to be helping?
It would be great. It's going to take a lot of work to get to the promised land, as it were. I would love to be the one doing it. I love building tools and solving the problems myself. But I think it's going to take a lot of partnerships between the lab, the researchers, and industry partners to really dig into the data that is held so close to the chest for a variety of reasons.
So if I hear you right, you're saying here's a funding source and scientific talent, right? Engineering talent to develop a product that will solve manufacturers' problems. Manufacturers just have to tell you what their problems are.
Yeah. Essentially, that's the whole aim, is that we're doing things to help our science.
Free solutions.
And then we're getting funded from taxpayer dollars through the DOE to do the work we do. And we have awesome people in Tech Transfer Office who come by and say, hey, you might want to talk to some people about what you're working on. And that's how we got forced out into the real world.
What are the AI models, the systems that you're using, developing? What are they called?
So the first kind of foundational models that we worked with were computer vision. So I sought to replace shift workers with AI solutions, because grad students at 2 a.m. working on PCs don't do a great job, it turns out. And there are many techniques being developed at Jefferson Lab involved with continual learning, federated knowledge building, and some of these techniques that I think can be applicable where there are privacy concerns. So we're looking at deep learning and those kinds of solutions, and not the 60s AI.
And, one thing that I've heard of that's a roadblock for a lot of factories to, at least in the U.S., to develop this, like the smart factory, to be able to communicate with the AI systems that you're talking about, is they don't have the equipment that's capable of recording and communicating this stuff. Is that correct?
Yeah. So what we've been finding is you go to Asia and they're very well instrumented. Around here, some people using, I'll call it legacy machinery that maybe isn't collecting the data. They didn't know it would be valuable. And it was nice hearing about Internet of Things being here, because I very much view that kind of technology as enabling AI. If you don't have the data, if you can't get the data out of the machines, you can't do anything with it. You can't take actions with AI. So I think the time is actually looking to be better than I expected in terms of bringing up AI solutions, because you're coupling it and building it off of the need for Internet of Things. Like, can we get these data? We need these data. Now we have something to chew on as far as the data science solutions go. So
if you get to the point where you have a solution, is that going to be made commercially available via distributor? Does DOE actually make that available? How does that retail model look?
That is actually one of our challenges. So we have a framework that we use in-house, and that's what we built. And it turns out nobody cares about a framework. They care about the product of the framework, and I understand that. But then the question that the DOE is asking us as part of this academic program is, how are you going to do it? So we started with a basic, licensing. We have software, you license it. But it's turned into more likely kind of an open AI model where it's going to take partnership. You partner with a company, you make their manufacturing better as a proof of concept, and you take the knowledge you gain there to go to the next one. And you are transferring, just like an employee working at one firm and then moving to a different firm, you're taking that knowledge without exposing the secrets of any party involved to enhance the manufacturing across the line. So I would see it, I think right now our top hypothesis is that you would do it through embedding yourself with viable partners willing to give you the data, work with you, devote the time, and then hopefully it would be made commercially available. I don't know, that's above my pay grade on how the licensing and all of that works, but that model of co-creation, I think, is going to be really important in this industry, as opposed to, here's a box, take it, plug it in.
Thomas Nataliia, what would be the ideal person you'd like to talk to right now?
Oh, I would love to talk more with semiconductor manufacturers. There's a lot of money. I think they are the most sensitive to changes in performance, nanometer tolerances.
Time out. American semiconductor only? You don't?
No. I would love to talk if any semiconductor.
Okay.
However, getting anybody from TSMC on the line is not something that's easy to do. We've been fortunate to talk to some people around, but usually it's dead ends because there's a lot of money in it, and loose lip sync chips, I think, is the thing. So we see PCB as being a better beachhead to prove out the technology, because I think you have similar challenges, especially with substrate-like manufacturing techniques that are coming up. I think now is the time to develop the capabilities to help enhance PCB in the future without locking it down like semiconductors. Otherwise, I would love to talk to more manufacturing, process engineering type people who they know their secret sauce. What is your challenge? Even though you have your secret sauce that is making you, how can we make your thing better, more efficient?
So just to be clear, ideal would be semiconductor manufacturers, but if you can't get them, you'd love to talk to PCB manufacturers, fab houses, assembly houses.
Fab side would be better for us than assemblers, but I think the promised land, right, of it would be wonderful to have an idea of we need a board that does this, and you go from the chip level, everything is produced, design and manufacturing coupled innately, because we hear a lot of complaints of bouncing back and forth. No, that design's not going to be manufacturable, and going back and forth. Number one, it would be wonderful to talk to more semiconductor manufacturers, otherwise fabricators. We would love to hear what your challenges you're facing. That would be great.
And the fabricator side, more American, or again, anybody?
We're focusing on American for obvious reasons. But of course, if there's somebody outside the U.S., we have talked to a couple people outside the U.S. If they're willing to talk and share their knowledge, we're not going to say no to more data, but we're focusing on domestic production.
If you come into the point where you are possibly in competition with a commercial solution, will you pull the plug or will you push forward?
We've talked to some people we would view as competition, partly to learn their war stories. I think that in a lot of cases, when you start talking about laboratory technologies leaving the lab, it isn't specifically a commercial interest. yes, there are powers that want money, but part of it is that rising tide lifts all boats. So I would like to think that we wouldn't be in direct competition, but of course, if there's a commercial solution that does what we do, I'm not going to keep pouring heart and soul into it. It'll just be like we should just maybe do that, or work with them on making their thing better. So I like to take a more cooperative than competitive a mindset in my work. But
If somebody wanted to reach you to talk about this, how would they do that?
you can email me at tbritton@jlab.org.
Spell that. Just
TBRITTON@jlab.org. And if you have some problems in PCB fabrication and manufacturing or semiconductor, I would love for Nataliia and myself to talk to you. We can be your therapist. It's okay.
Well, we all know that we need therapy. So thank you very much, Thomas and Nataliia, for joining us.
No, thank you.